So good morning, welcome back. We're going to do a new chapter. This is going to be on system of equations. And more specifically, we're going to be working with what we call linear equations. And we're talking about the type that involve that two-variable concept. So remember, those two-variable equations basically are what we describe as linear equations if they meet these conditions here. So notice that this equation, we have y equals x plus 2. We recognize that as a slope-intercept form. So this is going to represent a line. We've also discovered that x equals -3 is also going to represent a line. Now, to solve the system of equations, what we're going to be essentially looking for is we're going to be looking for where those two lines intersect. That point of intersection is going to be our solution. Okay? So that's our goal here. That point satisfies both equations, therefore it's going to be a solution. So our objective today, we're going to use a strategy involving graphing. So we're going to graph, we're going to identify that point of intersection, and also make a little note. If the lines don't intersect, there will be a solution, there will not be a solution in common. So if the lines don't intersect, there will not be a solution in common. So we'll take that as we come across. But hopefully, most of the math classes, they want you to find a solution. So chances are those two lines should intersect. But they will throw that extra wrinkle in there once you start thinking you know what you're doing. Then they'll throw some other scenarios that you have to kind of think through a little bit differently. So let's look at this first equation, y equals x plus 2. We recognize, remember the slope is the coefficient of x. We recognize that the slope is a 1 in this problem. Now, remember slope is rise over run, so it's a good idea to write that as a ratio. So we can write that as 1 over 1. And our b in this problem is 2. And remember the b is where it crosses the y-axis, so that's going to be our y-intercept. So we can use this information to graph the first line. So we have our y-intercept of 2. And from there we can rise up 1, run over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And I can also go down and left, down and left. And that also create a pathway for my line. So I can line those points up, and I can draw my solution here. So this is going to be the line for the first equation, and remember this line represents all the points that satisfy this equation. And I've identified a few along the way, but remember there's infinitely many points on that line. The next equation we have is x equals -3. We recognize that this isn't actually in slope-intercept form. So remember, since this is not in slope-intercept form, this does not have a slope or y-intercept. So we pick up on x has to equal -3. So that's locked in. So when we graph this, x has to equal -3, but the y can be whatever once. So in this case, I put -3, 0 as a ordered pair. X could be -3, and I could say y is equal to a 2. I could say x equals -3 and y could equal a -1. So again, when you have x equals a certain value, that value is locked in. The y value is not locked in, so we're allowed to move up and down. We just can't move any further left or right. So we can kind of see that that's going to be a vertical line. So that represents the second equation. Now, to solve the system of equations, what we're looking for is that point of intersection. And indeed, we do see a point of intersection right here. So we kind of see that left 3 and down 1 is our ordered pair. So -3, 1 is going to be our solution, that ordered pair. So it satisfies both conditions, and therefore it's our solution. So again, we're going to look at some examples where we're going to practice our graphing, but in a system, we're going to look for that point in common. And one of the strategies is graphing. But also that graphing is only good for whole numbers or positive and negative numbers. If we start getting into fractions and decimals, it's really hard to start graphing a lot of fractions and decimals. So we're going to probably need a better strategy down the road. So stay tuned and see what we can get into.